Hey everyone, Greg. I hope your weekend was enjoyable. It was pretty warm in Oregon today. I had a great bike ride with some friends Saturday, and I thought we'd look forward to next week. First of all, just a couple of notes on last week. People did pretty well. You want to be able to, we're up to the point now where um, the any descriptive statistics, mean, median, mode, uh, correlation, t-test 1 and 2 sample, and ANOVA, and what we're going to do this week, which is chi-square. You want to be very sure you know how to report it in APA format. And that sheet that I sent out, I've been using that for quite a while. You can go into the APA manual, and it's a little hard to understand. If you report the statistics just as that sheet shows, that's probably all you're going to have to do. If you report a statistic correctly, people are going to be able to read your paper and go back and go, oh, well, I know how big the sample size was. And they're going to be able to understand your result because they know how to report how the statistic is reported in APA also. So on the ANOVA, everybody did pretty well, except one of the things you want to keep in mind is at Concordia, there's going to be some quantitative research papers, I'm sure, and I hope to be involved in some of those. But for instance, when you're reporting the ANOVA, you just report the statistic. Now, you'll find some research papers where they put those other numbers in there, like the MS, the FS, and that's allowable. You're able to do that, but you have to understand what they mean. You have to do what's called defend a dissertation, which means if you believe that there was cause and effect or there was a relationship between variables, you want to be able to explain clearly how you came to that conclusion. And so you're going to have to know the statistics that you use very well. So if you don't understand a statistic, a number, it shouldn't go in there. Now, one of the things you'll find is that there are institutions, Harvard, many others, that do purely quantitative educational research. And virtually most of it is really hard to understand unless you're a highly trained statistician. But you don't want to try and put a whole bunch in that you don't understand. And even if you write a quantitative paper for Concordia, I believe they're going to be pretty sound, they're going to be pretty strong, but they're going to be pretty straightforward. And so trying to do what you don't understand will minimize the effectiveness of your work. So we're doing pretty well, but just make sure you know how to report the statistics correctly and that you don't add in what you don't understand. Okay, now as far as this week goes, this week we are doing what is called the chi-square tests, and there's two types. There is a chi-square test for independence, which will happen the first part of the week, and the second part of the week there is a chi-square test for goodness of fit, and they're both based on the chi-square distribution, but they're different in what they're used for, so we have to be clear on that. So let's talk about the first one, the chi-square test for independence of categorical variables. Okay, here's what that means. You have one categorical variable. Let's say it's the type of AP course a student takes, and the values of that variable could be AP Stats or AP Economics. Then you have a categorical variable called after school activities, and the values for that categorical variable could be playing in the orchestra and band or being an athlete. So your null hypothesis in a chi-square test for the independence of categorical variables are that the variables are unrelated. So it's as simple as this. Is your gender related to whether you play the tuba or not? So that's what a categorical variable is. So let me give you an example. So what you'll do in a chi-square test for independence is you will set up what's called a contingency table. Now I'll show you mine here. And according to this, if you're an AP Stat, we took a sample of, what do we have here? 40, 50, 60, 70, 80. We have 90 people. We have a sample. 10 took AP Stats and 10 were in the orchestra. 10 took AP Stats and 20 were athletes. I'm reading this upside down. 20 took AP Economics and they were in the orchestra, and 40 took AP Economics and they were athletes. Now, if this was your sample, it would be hard to reject the null hypothesis that the variables are not related. It looks like about 1/3 of AP Stats students are in the orchestra, and 1/3 of the AP Economics students are in the orchestra. So, the null hypothesis is that the variables are not related. Now, if they were, let's say you would have a greater tendency of the AP Stats people to be in music and the AP Economics people to be athletes. Well, then that sample would start to deviate from the ratios I just showed you. And the amount of deviation is what creates your p-value. And in this case, the alternative hypothesis is that the two categorical variables are related. They do have something to do with one another. So gender does have something to do with whether you like to play the tuba or not. And the test is very simple. It's not used quite often, but it can be used. And a p-value, a low p-value, means you reject the null hypothesis that the variables are not related in favor of that the variables are related. And again, you can't read more into it than is there. You don't know how the variables are related. You just know that they are. So that's a chi-square test for independence. We'll be doing that the first week. And there's a very great calculator that works with it, and we'll show you how to use that. The second part of the week will be devoted to the chi-square test for goodness of fit. And here's what a chi-square test goodness of fit does, and this causes quite a bit of confusion. A chi-square test for the goodness of fit, let's say, for instance, you'll have a null hypothesis. So let's say there's a null hypothesis about how many people liked the last movie. And the movie critics say that, well, the last movie, 50% of the people thought it was terrific, 30% of the people thought it was great, 10% thought it was okay, 5% thought it was blah, and 5% thought it was terrible. So that adds up to 100%. Now, that's your null hypothesis. That's what people think. And the null hypothesis could be about anything. To reject the null hypothesis, the sample, you take a sample, and the percentage in each of those categories would have to deviate enough to say that your null hypothesis, you were going to reject it. The categories don't break down that way percentage-wise. So that's how a chi-square test for goodness of fit works. And the null hypothesis is stated a little differently. The null hypothesis is, here's how we believe the variable is distributed. Kind of like in the one sample t-test we did, the null hypothesis was that the mean on the happiness scale was 3.2, and your alternative hypothesis was that it was not. Here, your hypothesis is about how a variable is distributed. 40% this, 30% that, 20% that, 5% this, 5% that. Your alternative hypothesis is that it's not distributed this way. And the chi-square test for goodness of fit is used quite often in quantitative research. So they're pretty straightforward. There's some nuances and some things we'll have to do differently. But this week we'll wrap up all the new inferential statistics that you will learn. And are we coming up on week 7 or 6? I believe we're coming up on week 7 after this. And that will deal with how we put all of these statistics together and to create what's called a true experiment. So this is the last week you'll learn about a new inferential statistic. So onward, we're doing really well. There was one other thing. Oh, please don't forget to fill out the instructor evaluation form if you would. I'd appreciate that. We use those to reflect on how we're doing and make improvements in the course. So everybody have a good week. I've only got a few more assignments to grade. I'm waiting to get just a couple of more in, and that should be done tonight or early tomorrow morning. I won't be available tomorrow. I work tomorrow night, and we'll have another good week. Feel free to call at any time. We will have our Friday night help session before we submit the assignment. And I appreciate all your work. Everybody just have a great week. Okay, bye.